Okay, hello, welcome. Today we're going to work with the sound and using the library OpenAL. But first we're going to turn our attention to the drum machine I got here. So here we got the circuit tracks, and it has tracks, the blue here, and sounds down here. I can press the start. I'm playing the track up there, different sounds. So I can lock in a sound at specific positions. That sounds good. And that's the most simple beat you can ever make. So that's what we're going to make in the computer. So we're going to have the Audacity to start the program Audacity and record some sounds. So let's hit the drum and see if we get the drum. So first we're going to go into setup, recording channels, and select mono, because we're going to move this sound in 3D and then we can't use stereo in the library I'm using. So we're going to record it in mono, press record, and there we have our small sample. It's really tiny, so there's a tool for that somewhere. Going to normalize it. Oh, we need to select it first. Okay. There we go. And then we need to cut out what we do not need. It's probably easier way to do this. I'm not good at this program at all. So let's call it sound 1, sound 0, because of the reasons. And then let's record the next one. And record it on the same channel here. Or track. I don't like that. Should have had an own one, but whatever. It's not a tutorial in this program. It's a tutorial how to make this work in C later. So effect, volume, normalize, apply. There we go. Zoom in. Did cut off a bit of the ringing in the end there of the sound. Hope it still sounds okay. And cut off a bit in the start here. Yeah, that's fine. That's fine. So let's create a program. So we're going to use the audio library. So let's include the header files from that one. And they have 3 header files. Like they have the OpenGL has the utility library. We also have a utility library here. And we have the audio library, and we have the audio library C, what stands for see you later. I do not know. We need to initialize the utility library. We need to terminate, shut it down after. Let's just compile that. Yeah, that worked. Okay, I found the libraries. That's at least positive. And we have our 2 sounds. So sounds. Horrible name for it, but okay, fine. Hope this is the correct. No, this was not. Need to escape the slash. And it complained about semicolon. Was that all? Unused, okay. So now we need to load these two sounds. That we do with allut load memory from file, and there are multiple allut load memory from file image, and a few different functions here. So let's load the first one, and after that it has a format. So it will figure out the format of the WAV file, which I hope is mono, because that's what I exported to, I hope. And after that it got the size, and after that it had format, size, and frequency. There we go. But the types for those, was it enum, format, size was an I size, pretty sure. Frequency I also think was an I size. Could be float also. I think it is a float. Unknown type, did you mean the C? ALC, sure. I size I, okay. Size integer, I guess. Okay, so it compiled, so that was correct. More or less, at least. It was correct, I don't know. Then we're going to load it to a buffer. And now I need the gink tool. That's a gink tool. There's a gink startup. There we go. Hello, while editing this I realized that I didn't explain what source were very well. A source is a speaker. And it's not the speaker as in my headphones. I have two speakers in my headphones. It's just a sound source. So that's why I call it source all the time. But it's a virtual speaker that we can translate in 3 dimensions and set speed too, so we get Doppler effects and things like that. So a source is a speaker. So we have some piece of memory with a WAV, and that one we're going to point it to a buffer. Buffer. I have space there. Okay, cool. And I have a source. And I have me, a listener. So we are loading the WAV files. I hope that already worked, so we have them in memory. We need to create the buffer, and that's like the OpenGL list almost. It's an object for the audio library. So we need to create one of those. And when we have that one, we have assigned the WAV to that buffer. It's probably because of all the hardware that could have the sound in memory, but have a sound card that probably could be like that, going to transfer over the sound into the buffer, because I mean technically we do not need it on the PC. And then we have the source, and we can have multiple of these guys, and we will have 2 of them, so we will have 2 sources, one for the drum and one for the other sound. And then we have a listener, and that's of course me, and we're going to assign a buffer each to each source. Then we play the source, and yeah, I'm be able to hear it. That's what we're going to do. But then we need first to load this to the buffer or create the buffer even. I think it's called buffer data. Let's start with that because it happens to have these variables. They use the same, so let's write them at the same time. We're going to assign the buffer, and we're going to have it in format, and we're going to use the first sound, and it has the size and it has the frequency. So there we go. Now we have loaded the first sound and assigned it to buffer. We haven't created the buffer though, we need to do that. But we also need to load the second sound. So let's not like that. I'm going to create a loop. And then just put in I here. So we're going to load first sound, format, size, frequency. I wonder, there should be data here somewhere. That should be a data object. That should be vav object. And we need to load it to some place because that's the file name, and it needs to format, size, and frequency, and it needs to be signed somehow. Vav. And that's a void, just the pointer. We have two of those. Don't need two of those because we're looping around here, but just make it simple. Let's have that. So we have a path to a file. We load that up, the raw data in there. It sets the format, sets the size, sets the frequency of the vav. Then say that we're going to put load this vav into the buffer, and it has a format, the data, the size, and the frequency. I think that's the order of it. Let's compile it. It's not the order of it. Buffer undeclared. Okay, of course. Haven't created the buffer. So let's do that. We have two of them though. It's gen buffers. And we want to create two of them at the same time. And then of course we need to delete the buffer. So when we are done, two of them, and that's a variable. Implicit delete, you mean delete buffers? Yes, I meant delete buffers. Okay, so now we have something that I actually compiled. Of course it doesn't play anything, but still better that it compiles than it does not compile. So we need our source. And what we're going to do in the end here is we're going to have one source, one listener, that being me, because I have the headphones, you don't. You need headphones to listen to this in the end, by the way. And another source, and these sources are going to rotate around while playing that stupid little beat. So let's create the sources. Two of those, and then delete them, and let's see which order I should delete them. I create the buffers first and create the source later. I wonder if that really matters, but delete the source first, then I'll delete the buffer. It sounds like a good idea. Because you load the vav into the buffer, and the buffer is pointing to the source, so the source might use the buffer, so delete the source before deleting the buffer. It sounds like a good idea. And then we should really unload this from memory, which I think this method do. I hope so. And that compiles. Yeah, it compiled. And we need to... this generates the buffer. This generates the source. This loads the data to the buffer, but we haven't set the buffer to the source. Source we have source, and here we also could use a loop maybe later. So buffer, and we're going to set the buffer. So assign the buffer to the source, and yeah, let's do that in loop. And should I do that after I load the data maybe? Technically, I don't think it matters because we generated the buffer on the source, even though the data isn't loaded to the buffer. I think it's fine to assign the buffer to the source. I think that's how you write it. Yep. And then we need the listener. Being me. I'm going to set the volume here. It's called gain. That's 1.0. I think it goes on 0 to 1. And we need to do the same on the source. Because the source, of course, can play the different sound in different loudness. I'm not going to mess with that to start with. It has pitch also. So you can re-pitch a VAV. And it has a position. Could set the position here. And it takes 3 floats. But then also we had 2 sources, 2 different sounds. There we go. See if that compiles. Yep, that's compiled. And we have the same thing on the listener. We can set the position. I think you can set the velocity also. And you can set an orientation, meaning where am I looking? More or less, where are my ears? The program wants to know where my ears are. But we're just going to use the default for now. So I think the gain would be probably fine for the listener. Maybe I should set the position also. Yeah, let's set the position of the listener. I guess that the default value are fine, but in case they are not. Then we need to play. Source play, play over source. And let's play both of them. There we go. Too many arguments for position, because it's 3 floats. Okay, so now it probably played some value, some sound, if everything worked, but it's also directly terminated here, so we didn't hear anything. So let's wait until the sound has played. And for that we need source state. We need to listen to the source and see its state and see if it's playing or not playing. And that has an int source state, maybe. So we're getting that with get source, and we want an int, and for source 0, that's why I call them sound 0 and sound 1, because that correlates to source 1 and source 0 and source 1. So we need the source play source state. We need a source state, of course, and that's going to be set in source state. So here we need a little loop again, and this time we're going to do a do while. Source state equals playing. So as long as our state for source 0 is playing, I'm just going to loop here. Very nice busy loop. And we're going to do that for both of our sources. There we go. And now I got a small sound. Did you hear it? Very corrupted though. So either I didn't manage to load the sound files, I didn't manage to set up the source, I didn't manage to set up the listener, or I haven't specified which sound card I should play it on. Now I did hear something, so I guess it's defaulting to something, but normally we should have a device, so let's add the device. It's actually played anything without the device specified. For me it's a little bit odd, but okay. And you can list the devices. If you have multiple sound cards, you can list the device and you can select the device sending in here which device you want. But if you set the 0, you're just going to open the default device on, yeah, you normally want to play it on the default device because that's what the user has selected in the computer somewhere. What's the default, and that's what we want to play it on. And after we shut everything down, we need to close the device again. So let's try that. And we still got an error. Compiled it though, so that's great. So let's see. Temp sound. So we have 2 sounds, so that seems to be the right location at least. Now I have coded this without error handling, and I won't make an error handling, and just fix it so it works. So it's the buffer, format, wav, size, and frequency. Frequency, size, format. We have generated the buffer. I'm pretty sure that that one is correct. The source, pitch, location, buffer, the source, and we have generated the source. Seems to correct. Set the listener. Start playing. What happens if we do not play anything? And it crashed. Wonderful. Okay, so I noticed that this should be float, that should be float, and that should also be a float because we're sending in a float, not an integer. But still, no luck. Well, should have said something. Probably should send in the variable I'm setting, and let's see if it works. Okay. Still hasn't the same beat that we had before. We need to fix that. So let's for we had 16 beats over there, but let's say 128 here. We're just going to say that if I happens to be modulus 4, so each 4th step we're going to play our drum, and the other one is every 2nd step, and let's ignore that I didn't play the last sound there on the tracks. And that went too fast. We need a sleep here for setting the timing. And that's in unit standard. So let's include unit standard. And we need some math functions also to spin it around later. So let's include that while we're up here. That's saying. So we got our float. We're going to, this is radians where we're going to put the sources. So let's create a radiant that's spinning around us. So it's 2 times pi. That's 14, 15, 92. And then we need to divide it by 128. So we divide all that by 128 steps, and all of that will multiply with I in float, because I want float out of this. So we're going to spin our sources, one there, one here, and spin them around that origo, and that's our radians. Going to use to spin it around. And then we need to set the position of the sources. So we have our two sources here, 0 and 1, and we have position, and let's say that we're going to have negative or sine f, and then we should have cosine on this one. And then we need to negate one of those if I want to have the sources on different sides of me. And it said F undeclared, because it was called an R, right? And I think it's cosinus float I should use as a double. Well, that didn't work. I mean, it's moving around, but it did work, right? Just a bit slow to move around. Let's fix that. Let's say I want it to move around 2 full rotations. Probably working now. You need headphones though to hear it. Let's say even 4 rotations. And that drum is very aggressive. Let's fix that. Where should we type it? Where should we type that? Let's type it in here. So let's decrease the gain of that drum. Now it's not as aggressive. And I don't like it. Let's pitch it up. See if we can modify the sound a bit. Maybe you could even change. Oh, I'm setting this to, I don't know what I'll set that one to. So it pitched up a little too much, I think. Yeah, it's not the best beat, not the best sounds for it. This actually sounds kind of horrible, I must admit. But let's have it like that. Anyhow, now we can play sounds on the computer, and I realized how annoying this is to listen to. So that's more or less that. I will check in this code. I think it needs context some here. You open a device and you set the buffer and source, and then you can set the parameters, and I think you can switch between different contexts. Okay, you can do that to OpenGL. I think this works the same. So I will see if I can fix that before I check it in. But yeah, now we got our bit. So happy coding.